In this problem, we learn basics of working with buffers. You have a buffer which is a combination of 25.0 milliliters of 0.362 molar formic acid and 12.5 milliliters of 0.672 molar sodium formate. Formic acid is a weak acid, and sodium formate is its conjugate base. The first initial step we would like to look at when considering the pH of a buffer system is understanding which buffer pH range can be targeted. In this problem, we're using formic acid and formate, and so we would like to know which buffer pH range can be targeted using formic acid. Since the pKa of formic acid is 3.744, the buffer range is 2.744 to 4.744, or 3.744 plus or minus 1. The buffer will be ineffective outside this range because its capacity will be very weak. We then write the chemical equation, which represents the dissociation of formic acid into its conjugate base, formate. Formic acid dissociates into H+ and formate. Finally, we write the equilibrium expression for this dissociation, where Ka is equal to H+ concentration times formate concentration divided by formic acid concentration. So in this equilibrium expression, we have the product concentrations divided by the reactant concentrations, where because we're using Ka, we have H+ in the numerator. First, to determine the pH of the buffer, we must calculate the moles of acid and base, given the volume and concentration of both the acid and the conjugate base. The moles of acid are equal to 0.362 molar times 0.0250 liters. These quantities were given initially in the problem. The number of moles of acid is then 0.00905. Similarly, to calculate the moles of base, we multiply the concentration of the sodium formate, 0.672, by the volume of sodium formate, 0.0125 liters. We then find that the moles of base we start with is 0.00840. Next, we use the Henderson-Hasselbalch equation. pH equals pKa plus log of the ratio of moles of base to moles of acid. In this problem, the pKa is 3.744, the moles of base is 0.00840, and the moles of acid is 0.00905. Therefore, using the Henderson-Hasselbalch equation, we determined that the initial pH of this buffer is 3.712. For the next step, we would like to determine the pH of the buffer after we add 1.00 milliliters of 1.045 molar sodium hydroxide. Our first step is to determine the number of moles of base that were added. We multiply the concentration by the volume, and we find that we added 0.001045 moles of base. We again use the Henderson-Hasselbalch equation. We then carry over the numbers from the previous step in this problem, and to the numerator of the log ratio, we have to add 0.00105 moles of base because that's what we added into this buffer system. We then have to subtract that same quantity from the denominator because as we added base, we consumed acid in order to maintain the pH. Our pH then increased to 3.816. Remember that when base is added, acid is consumed, so the quantity of base added is removed from the acid term.